Okay, this is another variety of problem that we're going to apply integration by parts to. And we do have a product here. We have the product of e to the 3x with cosine of 2x. So using our Liate rule, trig comes before exponential, so we're going to let u equal to the cosine of 2x. So dv is everything left over, which is just simply, excuse me, e to the 3x dx. So let's integrate here, and the integral of cosine of 2x is minus 2 sine of 2x, using the chain rule. And v, you got to integrate to get v, and that is equal to 1/3 e to the 3x. Let's put it together in using integration by parts, which is, remember it's u v minus the integral of v du. So let's put that together, and you've got u times v, which is 1/3 e to the 3x cosine of 2x minus the integral of v du, which is minus 2 sine of 2x dx. Oh, I didn't want to close that. So unfortunately, that integral, and we'll clean it up algebraically, didn't get very much simpler, right? It didn't improve too much. So we need to continue to work on this and see where we're going to end up. So this is equal to 1/3 e 3x cosine of 2x minus, there's a negative sign and a negative sign, so I'm going to make it a plus. I'm going to pull out all the constants, and we're left with 2/3 e to the 3x sine of 2x dx. So now we're going to work on this and see if we can get anywhere. So work on this. Right, this is the multiple iterations. Right? We're going to take that aside and do another pass. So this was pass 1. So let's take this integral and work on that. Again, using the trig functions, you're going to let u, using the Liate rule, trig functions comes before exponential, so we're going to let u equal sine of 2x, which would mean du is equal to 2 cosine of 2x dx, and dv is equal to e to the 3x, which is everything left over. V is equal to the integral of that, which is 1/3 e to the 3x. So let's put it together, and u times v is 1/3 e to the 3x sine of 2x minus the integral of 1/3 e to the 3x, and then du is just 2 cosine of 2x dx. Again, cleaning this up a bit. Algebraically, I'm going to pull the constants out in front. Here the sign stays negative, and the integral gets repeated. And hopefully you recognize that we're back to where we started from. So this was pass number 2. Let's go back and notice that that's exactly where we started from, right? We just ended up with the integral e to the 3x cosine of 2x. And so that's exactly where we ended up. Okay, so we went round robin. So let's try and substitute and then perform a little bit of advanced algebra on this. It's algebra. It's not something you're going to be used to seeing, the kind of algebra that you're used to seeing, but it nonetheless is just simply algebra. So I'm going to pick another color here. We're going to substitute back. Okay, so we're starting off with the integral of cosine. This is the integral that we worked on. 2x e to the 3x dx. Oops, I should have written it the other way. You know what, let me do that so I don't confuse you. E to the 3x cosine of 2x dx. Right? That was equal to, after the first pass, 1/3 e to the 3x cosine of 2x, right, plus 2/3, right, I'm going back here now, okay, and I'm going to substitute in all of this into here, okay. So I may have to go to another page. Let's see how this works. Or at least wrap it. Shoot, I can't fit it all. I'm going to wrap it. E to 3x sine of 2x. Right, I'm putting this in now. Minus, I'm going to have to wrap over here. 2/3 the integral of e to the 3x cosine of 2x dx. Close the bracket. Okay, so I just substituted in everything that I found from the second pass. Right, this is the second pass, into what I found for the first pass. So now I've got this algebraic equation. What I can do is try and, let's distribute in this constant. Okay, let's distribute in this constant. And I'm going to pull this back a little bit. So e to the 3x cosine of 2x, which was our original integral, is equal to everything over here, right, on out. So I'm going to rewrite the first piece. There's nothing that we can do here. And then I'm going to distribute in the constant. So the first one is 2/9 e to the 3x sine of 2x minus, I'm distributing this over to here now. Oops. Why that's not working. Okay. Minus 4/9 the integral e to the 3x cosine of 2x dx. So we've got one integral of e to the 3x cosine of dx over on the left-hand side, and we've got a negative 4/9 on the right-hand side. So I'm going to algebraically combine these terms, and I know it's not something you're used to seeing, but still, it's just algebra. I'm going to rewrite this as 9/9. okay, so that we have a common denominator fraction. So if I bring this term over to the left-hand side, okay, if I bring that over to the left-hand side, I'm going to combine them. 4/9 plus 9/9 is 13/9. The integral e to the 3x cosine of 2x dx. This is a really long problem, so just bear with me here. I know my video is getting long. 1/3 e to the 3x cosine of 2x plus 2/9 e to the 3x sine of 2x plus a constant, right? And I have been neglecting to bring that along. Okay, but the original problem was not asking for 13/9. It's asking for simply what's the integral of that evaluate to. So I'm going to apply another little algebra piece to that, and I'm going to multiply everything through by 9/13. So I'm going to multiply this entire expression through by 9/13. Right, what you do to one side, you got to do to the other side. Okay. So this whole thing is going to get multiplied. Imagine doing this problem in class. So this entire expression needs to get multiplied by 9/13. Okay, so when I do that, grab another color here. When I do that, these guys are going to cancel out over here, and then I have to take care of distributing that into each term. So on the left-hand side, we get what we were after, e to the 3x cosine of 2x dx is equal to the right-hand side. All right, I'm multiplying by 9/13. Okay, so just looking at 1/3 and 9/13 now, and that reduces down to 3/13 e to the 3x cosine of 2x plus, and now I'm looking at 2/9 and 9/13, and that reduces down to 2/3 sine. What did I leave? Yes, I'm sorry. 2/3. I'm forgetting. 2/3 e to the 3x sine of 2x. So what I could do is factor out an e to the x if I wanted to. Let's do that. Let me factor out an e to the. Let me pause here for a minute, make sure I didn't get my algebra messed up. Okay, sorry about that. I wanted to go off and make sure the algebra was okay, and here's where I messed up. I got distracted by one of my kids. So this is 2/13 e to the 3x sine of 2x. Okay, plus a constant. So we could clean it up a little bit more, and I will for you. Right, we could certainly factor out e to the 3x out of these terms on the right-hand side, right? So this is left-hand side stays the same. Factor out an e to the 3x. What's left inside? And we can also, you know what, I'm also going to factor out a 3/13. Okay, so if I factor out a 3/13, then we're left with inside cosine of 2x plus 2/3 sine of 2x plus a constant. Let me make sure that, let's check it. 3/13, I pulled out 3/13 times 2/3 reduces down to 2/13. Yep, so we're good. So this is your answer to the integral. Long way to get there. Okay, hope that demonstrates another approach to using integration by parts in algebra.